This video continues our discussion of Exam 2 review, problems 6 through 10. Of 540 seafood samples purchased in different stores in different sections of the country, 15% of them were mislabeled. Construct a 90% confidence interval for the proportion of seafood sold in this country that is mislabeled or misidentified. So I have by my side a scrap paper and a calculator. If you don't have scrap paper and a calculator, pause this video until you get one. So I'm going to be jotting down the sample size of 540. I know from past experience that StatCrunch is asking me for not the percent that were mislabeled, but the number that were mislabeled. So that's going to be 0.15 times 540. And I'm writing that information down. And then I'm going to also jot down a 90% confidence interval and the fact that I want the answer in percent form rounded to one decimal place. So first of all, we're going to pick up our scientific calculator. And we're going to enter 15%, 0.15, times the sample size of 540, and that is 81. 81 out of 540 were mislabeled. So we're going to go back to our problem, pick up StatCrunch, and we're going to go to Stat, Proportion, One Sample with Summary. 81 out of 540 were mislabeled. And I jot down, because I forget stuff a lot, that we want a 90% confidence interval, and we're going to compute. We're going to look at our boundary values and realize that they want things accurate to one decimal place, and they want it in percent form. So this lower limit would be 12.5%, jotting that down. And the upper limit is going to be 17.5%. And I'm jotting that down. I'm going to close this out and go back to my problem. So the lower bound is 12.5%, and the upper bound is 17.5%. What does this mean? It means that we are 90% confident that this interval captures the true proportion of all seafood in this country that is mislabeled. A government spokesperson says that the sample size is too small relative to all of the seafood that is purchased and sold per year. So what do we say about this? We say no. As long as the necessary assumptions are met, the results can be generalized. Check our answer. That's good. Let's move on to problem 7. A philanthropic organization sent free mailing labels to 100,000 donors. So that's our N equals 100,000. I'm jotting that down. And received 5,188 donations. I'm jotting that down. And we want a 99% confidence interval. So let's go directly to StatCrunch. Stat, proportions, one sample with summary. The number of successes is 5,188. They got that many donations out of 100,000 mailings. And we want, I'll have to change this, a 99% confidence interval. So the lower bound in decimal form is 0.05007, and the upper bound is 0.5368. So I'm going back, and I want it in percent form, rounded to two places. It'd be 5.01% and 5.37%. So, given the confidence interval you found, is the proposed rate of 5.5% plausible? Well, no, because it is bigger than all of the values in the interval. Let's check our answer. Okay, good. Notice that rounding was very important in this problem because they wanted two decimal places. That's why I suggest you write your decimal answer accurate to 4 places down on your scrap paper so that you will round it to 2 places appropriately. So, a polling company split a sample in half. They asked 539 respondents, generally speaking, do you think the death penalty is fairly applied or unfairly applied in this country? Then they changed the question around. They asked another 535 respondents, generally speaking, do you think the death penalty is applied unfairly or fairly? So they just changed the order in which they asked the question. So it seems like maybe order matters. 60% said, of the first question, 60% they said they thought it was applied fairly, whereas 75% of the second sample said it was it said that it was applied fairly. What kind of bias is this? We're going to call this a response bias. Sure enough, the combined sample has 1,078 respondents. We want a 95% confidence interval for the proportion of the general public when you combine the two samples. So in the first sample, 60% of the 539. And in the second sample, 75 of the 539 said it was fairly applied. So I'm going to get out my calculator and I'm going to do that computation. The combined success rate is 0.60 times 539 plus 0.75 times 539. So that rounded off is 728. 728. I'm going to back out of this calculator. And we are going to go to StatCrunch. And we're going to do the proportion thing again. Stat, proportion stats, one sample with summary. I'm sorry about this. Number of successes was 728. Number of observations was 1078. And a 95% confidence interval. So I'm going to jot down 4 decimal places, 0.6473 and 0.7033. We'll go back to our problem, and they want it in decimal form, not percent form, and they want 2 decimal places. So it will be 0.65 on one end, and it will be 0.70 on the other end. How does the margin of error compare when you pool it as opposed to separately? Well, the margin of error is going to be smaller because the sample size is larger. Good enough. That was a lot of work. So now we're going to our next problem. And what about vitamin D? It's really necessary. You get it basically from the sun, and if you don't have enough, you get rickets. So we're afraid that kids watch so much TV today and they're not outside, so they may be at risk, increased risk. So we looked at a sample, and I'm jotting this down, of 2,700 children, and 21% of them, jotting it down, are vitamin deficient. And we want a 98% confidence interval, jotting that down. They want it in decimal form, rounded to 3 places. Okay, so we're going to our calculator, and we're going to figure out 0.21 times the sample size of 2,700, and that turns out to be 567. And we're going to back out of that, and we're going to pick up StatCrunch, and we're going to go to proportion, one sample with summary. So 567 children out of a total of 2,700 were vitamin D deficient, and we wanted a 98% confidence interval. And we're going to compute and jot down. So we have a lower boundary of, and I'm going to put 4 decimal places, 0.1918, and upper boundary of 0.2283. And let's go back to our question. Our lower boundary is 0.191, and they want 3 decimal places, so that would be 0.1912. And for 3 decimal places, this would be 0.228. So we are 98% confident that the portion of children, not people, children, fall inside this interval. About 95% of the 98% of the confidence interval will contain the true proportion. And we're going to check our answer. It's good. I deleted problem number 10, so that will end this video.